Now, most of the world is online, but there are still many archives, receipts, and documents that hold age old knowledge. Even today, in many parts of the world, we rely on physical forms and paper receipts. If this information is not preserved properly, it will be lost. Optical character recognition, or OCR, models solve this problem by digitizing scanned documents and images into machine readable text. In this video, we will discuss the OCR models by Mistral AI and watch quick demos on how to use them. The first Mistral OCR model was released in March 2025, then OCR 2 came in May, and now we have the Mistral OCR 3. Now let's just understand very briefly how Mistral OCR works, and then we will go deep into the versions and we will see the latest version, Mistral OCR 3. The Mistral OCR models, they support state-of-the-art understanding of complex documents of various formats. They are also multilingual and multimodal. They support many languages and also documents with images and tables. They are also very fast because they are lightweight. And you can give your documents as prompts and then you get structured output out of the model. So let's see some examples of how this works. If you see, this is a document with various tables and figures, and this on the right hand side is the OCR result. If you slide this, you can see how well a document that has been scanned is being converted into text or images. And the same goes for a document with heavy math. And if you can see the math, the complicated symbols are converted correctly into the digitized format. Now this is, again, is a document in Hindi, which is an Indian language. And you can see that it's exactly converted into text. So it works quite well with many languages. And this again is in Arabic. And Mistral OCR models, they achieve top-tier results on various benchmarks, almost in comparison with Google Document AI and also Gemini models. Now let us see some of the use cases of OCR models. The first one is digitizing scientific research. So a lot of scientific research is written down by hand, and they can be easily converted into digitized documents, and they can be used for searching and cataloging through OCR models. And OCR models are also very helpful in preserving historical and cultural heritage. As you know, historical documents, they were all written on paper, and organizations and non-profit organizations, they can use OCR to convert them into digitized documents, which helps in their preservation. Another use case that is not usually mentioned in this context is customer service. So customer service departments, they are also using OCR to transform all their policies and documentation into indexed knowledge, so that they can be easily searched or they can be used in conjunction with a RAG system, and then again further support customer service. Apart from these, there are many other fields as well in legal and design and education, where all the engineering drawings and presentations can be converted into digital documents. So these are some of the use cases, but there are so many more actually. I remember having to write assignments by hand when I was at university, and then we had to scan them and submit them. When I see today's OCR models, I can't help but think it would have been really nice if those assignments were preserved digitally instead of just living only as scanned images. Another important application is that it's not just about the scanned documents. Even the PDFs we use today can be converted into plain text or markdown, which can then be again used in RAG systems or to be fed into LLMs. I personally find this OCR approach far more useful than relying on traditional PDF readers. Those use cases in action. If you see, this is a very archaic document. It's a contract, and the model successfully retrieves all this text from this document into the digitized format. So this is just one of the applications. Next, let's see some tables. And if you click on tables here, so here this complicated table with so many rows is successfully extracted. And then invoice, which is very similar. And like I said, handwriting, where you can kind of convert your assignments or any other handwritten documents into text like this. And now that we have discussed these use cases, now let's see the latest version of Mistral OCR model, which is OCR 3. And the highlights of Mistral OCR 3 is that it has 74% win rate over Mistral OCR 2. And in addition to that, there is a document AI playground in Mistral AI Studio, which we will see in a short while. So the major upgrade over Mistral OCR 2 is in the forms, the handwritten content, low quality scans and tables, like how we have seen now. Sometimes scans can be really noisy and they can have poor lighting. Even those documents are successfully extracted using Mistral OCR 3. And apart from this, the pricing, it is $2 for 1,000 pages, I think, which is like really reasonable. And if you apply a batch API, then again, there's a 50% discount where it reduces to $1 per 1,000 pages. And Mistral 3 is also available through API, and this is the name of the model. And so here, if you see, there are more examples. And the main thing is it can also be converted into Markdown, which makes it much easier to interpret tables. And again, this is again an old form, and this is a letter, and these can be easily converted into text. And even the benchmarks, Mistral OCR 3, again, it has surpassed other similar OCR solutions. And how is OCR 3 different from the previous models? So there is an emphasis on handwriting and also complex tables, where the table structures are more complex with merged cells and column hierarchies. So this is again these are the recommended use cases and applications. They can be used for creating end-to-end document understanding pipelines and also digitization of any handwritten documents. So now that we've gained some basic understanding of these OCR models, let's go to AI Studio and test it under the Document AI Playground. So you can go to your AI Studio, and if you scroll down, there is a Document AI section here. Here you can drop your files, either PDFs or images, and then you can just see how it works. Now here I will test the multilingual capabilities of these models, and you can just click on upload files and upload your images or documents. So first I will upload an image in German and try to extract the text from it. So here if you see, you can select your preferences, where this is the model, the response format. It can also be JSON, and images, pages select. You can also extract tables and extract headers, and you can change your settings based on your requirements. So now this is a German image where German text is inside an image. And now let's click on run and see how the text will be extracted. So it's just a text about someone's daily routine. And you can see that it is extracted word by word with 100% accuracy. So this is some Hindi text that has been written on paper, and now we want to digitize it. And so let's click on run. So this is a short Hindi text based on the environment. So if you speak Hindi, I think you can see that all the text has been extracted word for OCR Playground. where you can upload more complex documents and check it. And there is also this markdown option for PDFs. If you see, the markdown option will be more clear. And you, so this is how the document AI works. You can go and play around. Now, now the same capabilities that we saw just now are also available through API, and they can be used through using this Mistral OCR latest model. So if you see what are the key features, they're the same as we saw. They extract the text and also the tables. And the table can be extracted either as Markdown or as HTML for further rendering. So now let us just see the code of how this works. So in Python, what you can do is you can upload the file to Mistral using the files option, and then you can use that retrieved file and you can send it to this endpoint with client.ocr.process, and you can mention all your options here like table format and if the images will be included in base64 and whether you want a header and footer extracted. And this will be the output. So there is a JSON schema here where these are all the collection of all the pages. And for each page, you have all these properties, like any tables in the page or hyperlinks, the headers, and also other usage info and document annotation and the model used. So you will get this as a JSON schema, which you can further use in your applications. So this is one of the examples. You can also directly give URLs and also PDFs as base64 encoded bytes. And even in that case, the output looks very similar. So now that we've seen how the API works, let's just go through this cookbook, which is tool usage. Basically, it will show you how the Mistral OCR model, it can read the PDF documents or images in which are presented as URLs, and we can use Mistral small model to get the answers for questions from those documents. So let us see how it works. So this is a cookbook of the tool usage. So the OCR models, they transform text-based documents and images into pure text outputs and Mauta. Now here, there is an extra flow. If you see, this is the flow. We have two models here. This is the Mistral small model and this is the OCR model. So if the Mistral small model wants to use the open URLs method, then it will parse with Mistral OCR, and then the text comes back to the Mistral small model, which will then be used to answer the question. But if it can directly answer the question, the tool use will be no, and the Mistral small model will directly answer the question. Now let's see how this works. So first we install Mistral package, and then we set the API keys. And this open URLs is a tool, it's a function. So the Mistral small model decides whether it wants to call this or not. So for enabling this, we have the system prompt and this method perform OCR, where again we use this client.ocr.process. You can either use the OCR model for the document URL, or if it fails, then you can try with an image. So you don't know whether the URL points to a PDF or an image. So if PDF doesn't work and throws an exception, you can come here and try it for image. So that is what this code does, and it will return all the content as a string. So here, if you can see, this open URLs model, it calls the perform UCR and gets the content. So this is the tool calling. This is the tool calling schema that will be given to the model. So this the function name, the parameters, and also what are the required parameters. So now let us test this. So how we can test it is you can give a URL and then you can ask some question about the document or the image in that URL. And this is the script that can help you with that. This script, it runs in an infinite while loop, and it will only stop once you stop the execution of the user input is quit. So it will take the user input, extract the URLs from it, and decide if the OCR needs to be performed or not. If it's not necessary, it won't perform. Otherwise, it will read that entire PDF or image and then give you the answer. Now, let us execute this and see how it works. So for executing it and testing it, I'm using this PDF. So this is a URL and it points to this document, and I'm trying to test how the model will handle complex structures, complex tabular structures. Here, if you see, there are multiple categories. There is the year, there is also the location, and then there are also different kind of attributes. So let's see how it works with this. So now when I execute this code, it will ask me for some input. So I will ask it, what is the highest in 24 hours in 2008 in Australia? So let's see how it answers this question. And after you type your question, then you also attach the URL to it, and then you click on enter. So it gave us the right answer, which we saw in the document, which is 63.2. It's very good at understanding this kind of a little bit complicated tabular structures. And yes, you can continue asking questions like this. And now I will just quit, and then you quit. So if you see this code, it decides whether a tool call is necessary, and if it's necessary, it extracts the tool name, the argument, the parameters of the tool, and then gets the message and appends this message as the role as tool. And then at the end, you have the assistance response. So this is how the OCR works, and this is a very interesting cookbook. And there is also another cookbook where it shows how to use the batch API. And if you want to perform OCR for many documents or many images at once, I think it is more efficient for you to use this batch OCR, and it is also cheaper. It is 50% cheaper than the normal OCR. And yeah, so the limits are that the documents cannot be more than 1,000 pages. And there are different types of documents that are supported, even Jupyter notebooks, text files, PowerPoint, and different kinds of images. So I would like to say that this has multiple applications, and I would like to know your thoughts in the comments. Thanks for watching.